Hi. So in this video, we're going to talk about the vector product, which is sometimes called the cross product. And that is defined for two vectors, A and B. The vector product is defined as A cross B, which just stands for the vector product, equals the magnitude of A times the magnitude of B times the sine of the angle between them times a unit vector, perpendicular to both vectors. Okay? And what that results in is if you imagine a plane, A and B, the vectors are on a plane, the cross product is a perpendicular vector to both of them. So if you were to calculate the cross product of two vectors, it's going to be a vector perpendicular to both A and B. And another part of the cross product is that if you were to calculate the magnitude of A cross of A and B, A cross B, that gives us the area of the parallelogram that is made by A and B. So that is a property of the cross product. Using magnitude of A to magnitude of B times sine of theta, which is the angle between them, times a unit vector. This formula is in the formula sheet. However, a more useful version of it is the component form, where A cross B equals the matrix of IJK, A1, A1, A2, A3, B1, B2, B3, which is then calculated by just finding the determinant of those, which is also in the formula sheet. So that's going to involve us using our stuff from matrices, which hopefully we remember. Okay? So we might as well just jump into two examples. Express PQ cross PR in component form, given P equals 1, negative 1, 0, Q equals 3, 0, 3, and R is 5, negative 2, 2. So the first thing we're going to have to do is get PQ, which is Q minus P. So 3 minus 1, 0 minus minus 1, 3 minus 0, and PR, which is R minus P, 5 minus 1, minus 2 minus minus 1, 2 minus 0. So now we've got PQ and PR. We can now find PQ cross PR, which is just going to equal, using this formula, well, we can just jump straight to this part. We created the matrix of them, I, J, K, 2, 1, 3, 4, negative 1, 2. We're going to get I, then the matrix 1, 3, negative 1, 2, minus J, 2, 3, 4, 2, plus K, 2, 1, 4, negative 1. And then we can calculate that. 1 times 2, minus 3 times negative 1, minus J, 2 times 2, minus 3 times 4, plus K, 2 times negative 1 minus 1 times 4, which is going to give us 1 times 2 is 2, 3 times negative 1 is negative 3, so 2 minus negative 3 gives us 5i, 2 times 2 is 4, minus 12 is negative 8, and then it so becomes 8j. 2 times negative 1 is negative 2. 1 times 4 is 4. So negative 2 minus 4 is negative 6. So PQ cross PR becomes 5i plus 8j minus 6k. And that's us finding the cross product in component form. So if we calculate the area of the triangle with these vertices, remembering that If we were to find the cross product, that gives us the area of the parallelogram, which we could then just half. So really all this is asking us to do is find the area of a parallelogram and half it. So find the cross product and then half it. So let's find A cross AB and AC. So AB will be B minus A, so 5 minus 2 is 3, negative 1 minus negative 1 is 0, 2 minus 3 is negative 1, and AC, 2 minus 2 is 0, 3 minus negative 1 is 4, 4 minus 3 is 1, and now let's find AB cross AC, which is going to be ij, 3, 0, negative 1, 0, 4, 1, giving us 0, negative 1, 4, 1, minus j, 3, negative 1, 0, 1, plus k, 3, 0, 0, 4. So AB cross AC is going to give us I times 0 times 1 is 0, minus negative 1 times 4, which is negative 4, minus j, 3 times 1 is 3, minus 0, plus k, 3 times 4 is 12, minus 0, and so we're going to get 0 minus, so we're going to get 4i minus 3j plus 12k. And now what we need to do is find the magnitude of that vector, which is going to be found by (4 squared plus negative 3 squared plus 12 squared, all square rooted. 4 squared is 16, 3 squared is 9, 12 squared is 144. Plus 9 plus 144 is 169 equals 13, and therefore the area of the triangle, which is half of that, will be 13 over 2 units squared. So the main thing to take from that is how to calculate the cross product, because it's going to become useful in much more vectors, but it is using this formula. Okay? So that's the vector cross product.